Thank you very much, Matt. I always find it weird talking to a mic. I feel like I'm on X Factor. But luckily for you, I'm not going to sing. I'm going to talk about ML. So I'm going to be talking about shipping ML to the edge. So at Fuzzy Labs, we do a lot of edge ML projects. So we've got a decent bit of expertise in this now. So I'm hoping to be able to share some of that with you today. So we work on a lot of different client projects. We don't work with Ring doorbells, but a lot of projects that we work on from the edge point of view, I can't really talk about. So I've had to come up with a bit of a different case study. It's completely fake, but has some very, very loose similarities to one of our projects that we've worked on. So yeah, I like concrete examples. We've got Ring doorbells. Ring doorbells have created a state-of-the-art model to be able to who's at your door. But they've got a problem. Not everybody's always looking at the camera. They might be turned around. They might be too far away. They might be so close to the point where you can't tell who it is. So they came to us and they said, right, okay, we need to work out what's wrong with a potential image before we put it through the model, because if they stood too close, we're not going to be able to get a good match. So we need to be able to have a model that's able to detect that they're too close and tell them, stand back. And they want this model to be as small as possible because they want it to run on the device and use as little battery life as possible, because people complain about the battery life of the doorbells. They want to not take any more battery away. So just like any other projects, we kind of go through the MLOps life cycle. So there's kind of a few different stages to that: managing your data, training your model, evaluating your model, and deploying your model. Anyone that's worked with ML before, you're very familiar with that. So I'm just going to walk you through each of those stages and some of the things that we've learned along the way with those. It's not going to be a comprehensive guide. I could probably talk to you for hours about all of this, so I'm going to keep it fairly concise. But with managing your data, you've got all sorts of different elements to it: collecting, labeling, preparing. Oops, went too fast. I'm going to talk specifically about collecting, labeling, and augmenting in this section. So in this instance, which actually we get a lot, annoyingly so, if we didn't, my job would be a lot easier, but they didn't have any data to give to us. The data that they had was from privacy point of view. This is people's cameras. They can't give us that data. So we had no data to work with, which when you can't train a model is problematic, to say the least. But yeah, this happens a lot. So one of the things that you can do is look at open source data sets. So you want to try and find a data set that's as similar as possible to the use case you've got. While a lot of this is kind of relevant to the edge, is some of the techniques that we'll use to reduce the size of our models will impact the accuracy of models. So we need to be trying to do everything we can to squeeze as much performance, as much accuracy as possible. So from a data point of view, we can look at open source data sets. In this case, the wider face data set would be a good option for this project. Lots of images of faces, albeit not quite the same, but similar enough that you could start to use it, explore some features. But one of the things that's maybe more new, which is really quite interesting, is synthetic data sets. So synthetic data sets have been used for a long time in computer vision, but now we have the capability to create very, very realistic images. So in this case, this is created by Gemini. Obviously, you can tell it looks very, very realistic. So models can be able to learn the features that we need from images like this. But the benefit of this, I'm going to walk around a bit, sorry if that's annoying, Max. And some of the benefits of this is so labeling. So obviously it's one thing having a data set, but then having a labeled data set is a completely other ballgame. So often if you have a data set, you need labeling. You don't want to be spending very expensive ML engineer time on doing that labeling. So you'll look at something like Mechanical Turk. For example, in this case, you'd be looking at about 2p per image. It can be a lot more if you want more people labeling, but on average, about kind of 2p per image. If I want to generate images, it's actually less. So it's less than 2p per image to be able to actually generate these images. And the benefit here is we don't need to label it. Us prompting the model is giving us our labels. We ask for what we want, we'll get it. So yeah, it's a really kind of interesting new development within computer vision. There's a lot of interesting use cases. And then augmentation, so something that's kind of obviously around for a long time, but we can increase, decrease brightness, have blur, rotate, flip, how to add more diversity to our data set. But interestingly, we can also kind of use that to auto label. So say, for example, we wanted to say to the model, we wanted it to learn that an image was too dark to be able to try and get a facial capture. We can go, right, okay, we'll set a threshold with how much we augment. And then anything above that threshold, we'll put into the too dark data set. So again, trying to avoid us labeling images as much as possible. So now moving on to training, I could put loads on here, but I kind of kept it as concise as possible. But specifically in this case, we look at transfer learning, selecting a base model, and reducing model size, all very relevant to edge deployments. So starting with transfer learning, again, because we've got such a small data set that we're working with, we want to try and use other models that have been pre-trained, and then we'll just unfreeze the higher layers and just train those specifically for the classes that we need. One of the benefits here is that we don't need much data to get quite a good model. And one of the interesting things that we need to do within that is choosing a good base model. So we need a good base model to fine tune on. So this is where you want to be quite specific to the use case you've got. So in our case, we want our model to be small as possible. So we want to choose a model that's been optimized for edge deployment, mobile net, efficient net. But then we also want to look at the data sets that these models have been trained on. Where possible, you want to try and find a model that's been trained on a data set that's as similar to your use case as possible. So say, for example, you trained a model that was for medical instances. You want to try and choose a base model that's been trained with medical data. So then moving on to experiment tracking, this is so important. It's just helping keep everything organized. So obviously you'll be able to get your training metrics. You can track all of your different runs. You can track those to the models that they've trained. You can register your models so you know which ones you've trained with which different hyperparameters. And because if you don't do that, you end up with this. My model V3 best use this one final. I think we've probably all been there at some point with some file. And we want to avoid this as much as possible with our models because we'll lose our best one potentially. We might deploy the wrong one to production. And especially if we're talking about edge, where potentially we might have limited access to the models, the edge devices that we're deploying to, we can't quickly roll it back like we would in the cloud. We have to go out to site. We have to go and get hold of this device, change the model. So deploying the wrong model is really problematic. So yeah, please use experiment tracking. And so then, as I mentioned, we want to try and make our model as small as possible. One of the main things we can do here is reduce the network width. Try and simplify as much as possible. We have the neurons, which are in our hidden layer, which is this layer in the middle. We're just basically reducing the number of neurons, which is just reducing the complexity of the model, which helps to make the model smaller. Obviously, this does have an impact on the accuracy of the model, quite significantly with this if you go quite high on the amount of reduction you do, but it is a really useful technique to use. Another one within that kind of same range is quantization. Essentially here, for those that aren't familiar with this, we're just chopping off the decimal points. So this is for the weights of the model. The weights of the model is the main thing that uses up the space within our model. So if we can reduce that down as much as possible, that helps make a nice small model for us. Again, does have an impact on accuracy, but it's a much less impact than what we would see with reducing the network width. But you will want to monitor that when you come to evaluate the model. Again, lots of different things inside of evaluation. With this, I'm going to focus on prediction analysis and creating an eval data set. So again, we're working with a very small data set. In this case, we might be using heavily synthetic data, heavily augmented data. We need to keep this out of our evaluation set as much as possible. Our evaluation set needs to be as close to the actual real production data that we'll see as possible. And in a lot of cases, this means going out and taking your own pictures, which we've done that. It seems like a lot of effort, but it's worth it because your evaluation data set is the one thing that you can hold to when you're trying to explain to people this is how accurate a model is. You want as good as possible data to make that benchmark reliable. And then we can use things to look at the prediction analysis. So in this case, GradCam, lots of different ways of looking into the predictions, but this helps us understand what is our model looking at. So in this case, we can see the heat maps of what's made the model make the prediction that it did. And again, helps with explainability, especially when you're kind of working with clients. They want to know why is the model making those predictions. This helps with that. And then error analysis. We want to look at, okay, when the model's making incorrect predictions, let's have a look at why. So let's look at all of those incorrect predictions. Can we see a pattern? If there's a pattern, we can then start to look at our data set that we're trained with, maybe our way that we're training the model to try and address that and improve the accuracy as much as possible. So then coming to final point, gosh, I feel like I've talked quite fast here. I'm sorry if this is quite a short talk. Coming to deploying the model. Again, we're going to talk about one specific thing here, which is deployment tooling. So for every single different device that you'll deploy to, generally there'll be some kind of toolkit that you can use to help deploy it with. The one that's kind of really useful is Platform.io because it works across lots of different architectures, lots of different boards. Essentially with these, they're just helping reduce the friction that you would have with deploying, building, maintaining and deploying models to those edge devices. If you don't use these, it can get really quite complicated. You can spend a lot of time trying to get that deployment right. And I think it's probably leads quite nicely onto our next talk, because I think that will be an example of some more deployment tooling. Yeah, really, really useful tool for doing that final bit, which otherwise would be a right pain. So to summarize, I think we've learned a lot from how doing these edge deployments. There's lots of different things you could go into. Like I said, I could probably talk for hours, all the different things that you want to try and do to optimize your models. But it can be hard. And often you're not going to have a great data set to work with, more often than not. So there's things that you can do, like I've mentioned, to try and improve that. So yeah, hopefully some useful nuggets in there. If Don't Ring Doorbells give you a ring and ask you to train a model for them, you've hopefully learned something tonight that'll help with that. Thank you.